Testing, testing. Testaroo. 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 Testing. Hello. Can you hear me? Hey, how's it going? Can you hear me? Hello, hello, hello. Hello, hello. Hello. I'm typing. Ah, awesome sauce. Cool. All right, well, let's go ahead and get started with this little live stream here. Let me check what time it is. 8:07. We got a couple people. So thank you. So yeah, I'll just go ahead and go through. I just wanted to do like a little half-hour review of functions, and I know there's a little bit of a delay here, so we'll try to allow for that in case anybody has any questions or anything. And I'll pause every once in a while, but I just wanted to run through really briefly. Again, try to keep it a half hour, no more than that, because people got stuff to do on a Saturday night. Well, maybe not. Hopefully, you're all sheltered in place. I don't know if you saw it or not, but there's a news story last week. They had some free testing in Hayward, and for coronavirus, 200 people who had the flu-like symptoms showed up. 50 of them tested positive for coronavirus in Hayward. And so if there's a 1% mortality rate, that means that 2 of those people who showed up that day will be dead by a month from now. So make sure you're taking care of yourselves, and don't do anything crazy. Wash your hands, practice physical distancing, take care of yourself and your families. But anyway, so just wanted to go through the basics of functions. I'm not going to do anything too deep, too complicated. Try to keep it short. Just want to remind you what functions are, how they work, and so I guess let's start. So at the core, a function is just a way to label some code so you can reuse it over and over again within your program, right? So we already know that if you want to print hello, say, right, well then you can just call the print hello function, and then if you run that, you can see the output there. There you go. But if you wanted to, let me give you another example. If you wanted to print out a certain number of stars on the screen, I can't get away from these star things. I might do something like this. This will print out 5 stars on the screen. We'll put nothing in between them, so no separator. And then after that's done, move to the next line. So you can do that. Print 5 stars. Oh, I want to put them all in one line, so forgot to turn off my end also. So there we go. There's our 5 stars. Now, anytime that I want to print 5 stars on the screen, right? Yeah, I know it's insane, and we're the #1 country in terms of infections in the world now, which means we're gonna have the #1 death toll. So get ready for it. But anyway, so if I wanted to keep printing these lines over and over again, right, I could just copy and paste this stuff, right? If I copy and paste that 5 times, well, there you go, right? Now, even better would be than copy and pasting would be, put that inside of a loop, right? So right here, I could just repeat by putting this all inside a loop. I could say something like, for j in range of 4, and put all that in the body of that loop. Fine, nested loops. Okay, cool. But instead, as an alternative, I could just put all that code, that for loop for printing out those stars for on a line. Anytime I want to repeat that code ever, I could, let's see here, dedent. I think that was called dedent. Okay. I can put it in a function instead, right? So remember what you need for a function definition. Right? You need to have that def keyword, you have to have the name of the function, and you have to have a parameter list, and you have to have the body of the function. Right? So the body of the function contains all the code that you want to repeat whenever you call that function. So I want to repeat all of this code right here whenever I call the function. So I'll just define some function, and use that def keyword, and then you can call it whatever you want as long as you follow the names of or the rules for identifiers. So print stars. Let's call it print stars. Right? Now, for this first example, I won't pass any arguments, so my parameter list is going to be empty. Right? Don't reach colons after this stuff, right? It seems like there's these single colons at the end of these little headers, right? So this thing right here is called the function header, right? You also got loop headers. Anytime you have a header like that, you're putting a colon after it. And then the body of the function or the body of the loop has to be indented one level. So I'm going to take all this stuff right here that I want to repeat over and over again, and I'm going to add that to the function definition, right? But I got to make sure that that's all indented, right? So this entire thing right here makes up my function definition, okay? So now anytime I want, this is my function definition, right? So anytime that I want to execute this code now, all I have to do is call that function. And you already know how to call functions, because print, that's a function call. Print is a function. It's just a function that's built into the interpreter, right? It's built into the language. You didn't write that function, but it's still a function. Now print stars is a function that I just wrote, right? So I can call it whenever I want. So this is what that function call looks like. Here's a function call to print stars, okay? And I know it's a function call because I got those parentheses at the end of it, right? Now parentheses are empty because I'm not passing any arguments to it, but without those parentheses, it's an identifier. It's like a variable name, right? So you got to have those parentheses even if they're empty. So that's going to be a function that is accepting no arguments, right? So no arguments, right? So let me run it. So you can see there's those 5 stars that were the result of that function being called. And as soon as that function's called, you jump up to the body of that function, you start executing code, right? So anytime that I want to execute that code, I can just call the function, right? So call it 4 times. So I see 4 rows of stars, fine, right? But don't repeat yourself as much as you can help it. And this is repeating myself, right? Rather than copy and paste that 3 times, put it in a loop, right? So I can put it in a loop as well. I'll do a while loop this time. So while I less than 4, say, right? And then I'll have to increment my I. Okay, so I can do something like that. Let's see, what did I miss here? Oh, mistyped it. While I, there we go. Okay, so print stars, that's going to execute 4 times because this loop is going to repeat 4 times, right? So you can combine these ideas. I mean, that's what you're doing when you're writing programs. And the more you learn how to program, the more you learn how to do stuff like this. Everything kind of builds on each other, right? So, that's the basics of defining a parameter list, or a parameterless function. No parameters, right? So, got that def keyword, you got the name for the function, and you have its parameter list. Parameter list right now, empty, because this thing doesn't take any arguments. And then this is the body of the function. Fine, right? Now, you can pass, right? No parameters here. So let me just make a couple more comments here before I move on. No arguments go into this function. And another thing to note, let's see. This is a void function. It doesn't return anything. So no return statements, okay? And I'll give you an example of a function that accepts arguments, a function that returns something, and then I think that'll be about everything I want to do here. Right? I want to keep it short. It's not going to be like a full-on lecture or anything. I just want to keep your brain fresh on functions over the spring break or over the break, right? So let me get rid of this function call here, okay? And let's write another function, okay? Another function. We'll call this one show numbers, okay? Or show number. And this function will accept a number as an argument and print it on the screen, right? So something really, 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 really simple. So in order for a function to accept an argument, you have to include a parameter, right? So in this case, A is the parameter, right? So I got one parameter. That means this function must accept one argument. Okay? So when we call this function, it's going to require us to call it with a function call that looks something like that, right? So the 5 is going to be assigned to the A, and then show number can use that 5. Okay, so keep it simple. We'll just print, hello world, hello, your value is, right? And then we'll just print the A. Okay, let's see. Why am I green? Oh, mismatched, mismatched quotes. Okay, so when we do that, this parameter is in the scope of the function, so you can use it anywhere in the function body and only within that function body. So now, when I call the function, say that I pass it 10, right? 10 and A, they're basically the same thing at that point. So when we run this, call the function, this print statement's going to execute, and we're going to see, hello world, your value is 10, right? So there's the 10 being passed as an argument. So in this function call, 10 is the argument, right? And in the function definition, A is the parameter, okay? Now you can have, okay, I'll just comment that out, leave it for you if you want to review it later, but I'll post this code on Blackboard. But you can have as many parameters as you want, right? So if I wanted to find the average of 3 numbers, for example, right, then I can put in 3 parameters, and you can name parameters whatever you want. I mean, you can name them, anything: fish, dog, cat, rat, bat, mat, whatever, so long as they follow the normal rules for naming stuff, for identifiers. So this function, its inputs are going to be 3 numbers I want to find the average of, right? And its outputs are going to be, we'll print the average on the screen, and then we'll modify it. For right now, we'll just print the average on the screen, but as soon as we run this and test it, then we'll have it return the average, right? So how do you find an average? The average is going to be equal to A plus B plus C, divide that by 3, right? And then we can print that average on the screen, okay? So we'll call that, so call find average, and since it has 3 items in its parameter list, which I'm calling A, B, and C, then it's going to require 3 arguments, right? And the order matters. First argument goes to the first parameter, second argument goes to the second parameter, third argument goes to the third parameter, right? So when I call it, find average, maybe I pass it 8, 6, 7, okay? Anytime I want to find average of 3 numbers now, all I have to do is call find average. I don't rewrite out all this code here. I just call the function, right? I'm reusing this code every single time. Okay, so let's test it. So there's our average, 7.0. 8 plus 6 plus 7 is 21 divided by 3. 7.0. Okay, so that works great. Now, as arguments, 8, 6, and 7 are the arguments, right? But you can also pass variables, as arguments. Right? So I could create x equals 2, y equals 4, z equals 1, right? And then I can call find average and pass those all as arguments. So x, y, and z are now the arguments. And you can mix and match too, right? 8, 6, and 7 were literals that were passed as arguments. X, y, and z are variables that are passed as arguments. I mean, I could have passed 8, 6, and z if I wanted to. Fine, no problem. You can mix and match that stuff. So now when I run that, you see the average for 2, 4, and 1. So 2 plus 4 is 6, plus 1 is 7, divided by 3 is about this, 2.3333335. Now if I want to round that off to 1 decimal place of precision or 3 decimal places of precision, then what I could do is I could come in here and I could maybe use the format function. That's what we covered. I mean, there's other ways of doing it too, but we covered format. So I'll throw that in there just to remind you about it. Oops, sorry. Fingers are all over the place. So 3 decimal places of precision, right? So now when I run it, you can see 2.333. Right? So you can format that output. Now every time I want to find the average or print the average of 3 numbers to the screen to 3 decimal places of precision, just call find average. I don't have to rewrite all this code every single time. Right? That's one of the main benefits of functions is code reuse. Okay, but so that's find average that prints the average to the screen. Now let's do another example here, and I'll comment out this stuff just so it's not spamming our screen. Let's talk about a value returning function. So find average here, this was also a void function, because nothing comes out of it. Show number is a void function because nothing came out of it. Print stars was a void function because nothing came out of it. Remember, it just means no return statements. Okay, so the print function, for example, is a void function. Find average is a void function. Why? Because I can't do something like this. Right? It makes no sense because there's nothing coming out of find average. Now find average ran, but look what happens when we print x. Right? It says none. Right? Because find average doesn't return anything, and so Python put none inside of x. Okay, so it's not necessarily a syntax error, it's just that it's a void function. It doesn't return anything. So if I wanted to have that average inside of x once find average was done, well, I'd have to do something different. Okay, so prints none because find average is a void function. It returns nothing. You get nothing. Right? So how about we write a different version of it? How about a version of find average where you can actually get the number out? Right? You can get that average and put it in a variable for further processing. So how about a version that is not a void function? Right? That's a value returning function. Right? So that way we can use the average once the function is finished executing. Right? We want to be able to put that average into a variable back in our program. So let's call this returning find average, I guess. Right? And I'll name this rat, cat, mat, just to show you, you can name this stuff whatever you want. So we'll compute the average in the same way. Rat plus cat plus mat and divide by 3. But instead, I'll use a return statement. Okay? So this statement makes it a value returning function. Okay? So let's call it and see how things change. Right? I'll go ahead and comment out all this stuff. Okay? So with value returning functions, you can assign them. You can assign the function calls of value returning functions two variables, right? So I could do something like this. I could say, average equals, and what do we call this up here? Return find average, right? Returning find average. So I'll pass to it 4, 1, 5. Okay. So when I do that, and I print out average, we're not going to see none anymore. We're going to see what the average was, 3.333335, because 4 plus 1 is 6, is 5, plus 5 is 10, 10 divided by 3 is 3.33333335. Where'd the 5 come from? Remember, floating point numbers subjected to rounding errors, okay? So this return statement right here, return average, that's what makes this possible, the ability to assign that function to average and then take that value that was returned and put it into this variable right here. Right now, another thing you can do is use, I'll comment this out too. Just want to show you like 2 more things, and then I'll ask if you have any questions or anything. Get you out of here. You can have Boolean functions, right? And this is interesting. Right? So you can have Boolean functions. That is functions that return true or false. If we want to pass user inputs to average function, should we leave it empty? Well, I'm not sure what you mean by empty, right? I mean, you can pass. Remember, let me answer it this way, right? So remember this example right here where I said x equals 2, y equals 4, z equals 1, and then I said find average x, y, z. Okay, so what's inside the x? Well, the 2 that I just happened to assign there, right? So if I wanted to pass something that the user gave me, well then instead of assigning 2 to x, I would just use input, right? Just like you have in the past, right? How the value gets into x doesn't matter as far as the function is concerned, right? So let me give you an example of that, right? So yeah, let me give you an example of that. And well, for this, let's let the user control how many stars get put on the screen, right? So let's go back up to that print stars function. Okay, so that print stars function right now, it doesn't accept any arguments, right? But we can change that, right? So we can put a parameter here, num stars. Okay, so I'll use that num stars parameter as an argument to the range function, right? So now whatever's passed as an argument is going to be used by range to determine how many repetitions this for loop is going to have, right? So we'll ask the user how many stars you want. So stars equals int input input enter a number of stars, right? And then I can call that print stars function, right? And then since this has a parameter now, I'll pass it a number as an argument. So in this case, what I'll pass will be what the user put into stars, right? So let's see that play out. So enter the number of stars. So I'll type 6, right? So now you see 1, 2, 3, 4, 5, 6, right? So that 6 that I typed, right? That was returned by input as a string, which was fed into the int function, and then int converted into a number, which went into stars, and then that number inside of stars, that 6, that then went into the parameter. Where are you? Here we are, num stars. And so then this became for I in range of 6, and so we had our 6 repetitions. So I'm not sure if that answered your question or not. Yeah, so I mean, you just combine all these things together. And so for the average function, when you were asking about that, when you call a function, if it has a parameter, you have to pass it arguments. Now, where those arguments came from don't matter as far as the function's concerned. Could be in variables, could be literals that we passed. Now, how did the value get into the variables? However you put them in there, right? Maybe you use an input statement. Maybe they were the result of you doing some kind of arithmetic expression. Maybe it was because you just did something like x equals 2. Yeah, I mean, it just totally depends on what you're trying to do, right? And the more you code, the more, just stupid little programs you write, the easier it becomes and the more natural it becomes, right? Just to want to encourage, people in the chat, as you're learning to program, there's a lot of stops and starts. There's a lot of banging your head against the wall. There's a lot of, my God, why doesn't this work? Or how come this doesn't make any sense? Or what the hell's going on? That's totally natural. It's normal. Don't get discouraged. You just got to keep working at it, keep working at it, keep working at it. And every little minor victory you have, the better you get. That's totally normal, right? So just stick with it. Right. So let me take another just 15 seconds to see if there's any other questions before I finish off with the last couple examples. So I think you guys are on a little bit of a delay anyway. I don't know why. It's just the previous stream I did with a different class, they were on a little bit of a delay. So I'll just wait about 15 seconds. Maybe I'll sing too. Yeah, I mean, with functions, that's the thing. It's once you learn them, you're like, why was that ever so hard? But I mean, when you're learning anything in programming, it always seems hard, right? I mean, I think once you get to a certain level, it's not hard to learn anymore because you have enough of a foundation how things just work in general. But when you're first starting, everything's mysterious, and your biggest enemy is just overthinking everything, because you have to think that everything is harder than it actually is. It's just natural. It's just, I mean, of all the 1,000 students I had, even when I was a student, it just seems to be the way it is. People, and then when people are doing homework assignments and stuff, they just make stuff up. They're like, well, I think I'm just going to do this, and you're like, well, where did that come from? And the student's like, well, I don't know. You're like, what are you doing? Okay, right. So let me just do 2 more quick little examples, and then we'll get out of here. Unless anybody wants me to do anything else. But anyway, so value returning functions, or Boolean functions. Okay, Boolean functions. They return true or false. Okay, and typically these functions usually include some kind of verb in them. I mean, they're usually, the names of the functions, I should say, are phrased in a way that makes it sound like they're a question. Yeah, the book is pretty good. I mean, Gaddis is pretty good. This book right here, it's got some problems with it because it's only been through 4 editions, and it's an adaptation of a C++ book. But if you're going on to the next programming class at CS2EB 201, it's the textbook that you use for that is by the same author. It's going to be very freaking familiar. You're going to see what I mean by the fact that he just adapted his previous work for Python. That's pretty much all he did. You're going to feel really comfortable transitioning, I think. But anyway, so these things are usually named with some kind of verb in the name to make it look like you're asking some kind of question. So is even, for example, is even, right? So you want to determine if some number that you pass to the function as an argument is even. Is this thing even or not? So what you can find out if a number is even, divide it by 2. If there's nothing left over, if the remainder is 0, it's even. Otherwise, it's odd. So you can do something like this. You can say, well, if the num modulus 2, right, because that's find the remainder of the number divided by 2. If that equals 0, then it's an even number, right? So we'll return true, okay? Else we'll return false, right? There's only 2 possibilities. It's either even or it's not, okay? So now we can use this functions anywhere you could use what they return. right? You can use the function called. So if you got a function that returns like 6, right? Well, then you could assign that function to a variable to store the 6, or you could use it as part of an arithmetic expression, for example. Or in this case, since this returns true or false, you could use it in a test expression, right? So maybe something like this, right? How about some how about a little reminder of input validation loops too? So you can say something like, enter a even number, right? And so remember how input validations loops work is that you have a loop that follows your input statement, and you say, well, while it's not good, right? While that thing is not good, we're going to have a loop. We're going to enter the body of the loop and ask you to give it to us again. So while not is even number, right? So whatever number that they give us, we pass it to is even. Is even's going to evaluate that number, and if it's even, it'll return true. Otherwise, it'll return false, right? So while it's not an even number, well, not is even. Nobody ever accused programmers of knowing how to use grammar, but there you go. While the number is not is even, well, not is even number, print your error message. Error, I said an even number, right? And then we'll ask him for that number again, right? And then once they give us an even number, then this test expression will evaluate to false, and then we'll get past the loop. So print, you figured it out. Congrats. Right. And this is going to work because is even returns true or false, right? And then true or false becomes an input to not, becomes the operand for not, and so the whole thing will evaluate to either true or false. Remember, not just flips the truth value of the true or the false that's given to it. So enter an even number. So I type 5. Right. Error, I said an even number, enter an even number. So when I typed that 5, that ended up in number, right? Number got passed to is even. So 5 gets assigned to the parameter. 5 divided by 2 has a remainder of 1, not 0, right? So this returns not true, but false, right? So when we come back, this becomes false. So while not false, well, not false is true. So while true, test expression is true, you enter the body of the loop. Okay, and so here we are. Right, so I can do 3, I can do 1, I can do 9, but as soon as I do that 8, right, well, then it's not false anymore, right? Or excuse me, it's not true anymore. So when I get that 8, where'd you go, Boolean function? There we go, is even. Oops, there it is. So 8 gets passed into num. 8 divided by 2 is 4 with a remainder of 0. So this is true. So we return true. And so then this true, this gets replaced by true. So what's not true? False. So this whole thing's false. And so the loop's done. And so we pass over it and the program continues. Right? Maybe that might be a little confusing. So here's another way of looking at it. What if I said enter odd number instead, right? Well, then it might be easier to see, while the number is even, or while is even number, then tell them, no, I said an odd number. Right? So now I'm asking for the opposite, so I got to change my logic, right? So if I type in 6, right? Well, it's true that 6 is even, so this is true, so we enter the body of the loop. Right? Similarly for 4, similarly for 2. And then, if I were to type, 9 now, well, no problem, right? Because this returns false, right? So the test expression is false, loops over, figured it out, congrats. Okay, so one more thing. Oh, we can actually shorten this up, I think. So We could chart it up a couple different ways, but I want to try this. This is something I like to do in most languages. I'm pretty sure Python does it too. Just something like that. I don't even think we need the rest of this stuff. We'll try it though. Right? And if it works, I'll tell you why. Enter odd number 4. Yeah, it worked. Right, so what happened? Well, this whole thing right here evaluated to true or false on its own, right? Because remember, we were using it as part of the test expression for if, right? So this thing returns true or false, or evaluates a true or false. So I'll just take what it evaluated to and return that. It'd be similar to if I tried to, maybe return for the average function, right? For the average function, I could have just did this, return rat plus cat plus mat. I don't have to put it in a variable first. Okay, so you can do that. You just want to experiment. That's the best thing you want to do when you're learning a language, any language. What if I do this? Can I do this? Does this work? I want to do this thing. Last thing about functions, you can in Python return more than one value. Right? I think I'll leave it at that. Then we'll get out of here. So functions can return more than one value. Right? So you can return a list of values. So how about a function that converts, here's a function that converts inches into feet and inches. And we'll do that. So define inches to feet and inches. Right? So this is going to take one argument and you're going to return two values. Right? It's almost kind of like passing arguments in reverse. So we'll call this just inches. Right? So how do you figure out how many feet there are in inches? Well, feet is going to be equal to inches, and here we're going to use integer division, right? Because I don't want 7.2 feet. I just want to know how many feet that is. Just feet, 7 feet, right? Because if you're 74 inches tall, I don't say, in terms of feet and inches that you're 6.2 feet tall, right? I'd say you're 6 foot 2 inches, right? I'd say you're 6 feet 2 inches. So I want to know exactly how many feet there are here. So divide that by 12, right? Using integer division. So that's going to give me, if I pass 74 as an argument, that's going to give me 74 divided by 12 without any decimal places. So that'll give me 6. I'll go into feet. Okay, now inches, we'll call them ins. Here we want to know how many inches are left over, right? If you're 74 inches tall, it means you're 6 foot 2. So here we'll divide inches by 12 again, but we want the remainder. We want what's left over. So modulus, right? So this right here is going to give us just the feet, and then this will give us how many inches are left over. Okay, so if I want this function to return both of those things, then I can return both those things, right? Just like, it looks a lot like the parameter list in that you got that comma in between. So to use this function, right, we're going to call the function just like we have all the others, okay? And we'll pass it some number, either a variable or a literal. So I'll pass it 76, right, for 76 inches. And then it's going to return two values. So I got to have two variables to accept the feet and inches, right? So then once that's done, f is going to get stored inside of it, the feet, which was inches divided by 12, which in this case will be 76 divided by 12. And then I is going to have the remaining inches, which in this case is going to be ins, and it's going to be 76 modulus 12, right? So it's finding the remainder of 76 inches divided by 12. That's how many inches you have left over, right? So print total feet, it's going to equal this, right? We'll say f, and then total inches. So then I'll run it. Okay. So if you're 76 inches tall, then you're 6 foot 4 inches, right? Converting inches to feet and inches. Right? So I think that's right? Because 76, let's see, 6 times 12 is 72. So that'd be 72 inches with 4 left over for the 76. Yeah, so that's right. So I think that's everything I wanted to show you really quick. I definitely wanted to try to keep it to a half hour. I think I'm about there. There's more stuff in the chapter, right? You're responsible for what you're responsible for. I just wanted to go in and with this live stream, give you a little bit of a review, keep your brain, a little in the loop, as it were, on functions, give you a little bit more exposure to it. But this isn't all. This attending this live stream was optional, and what I've covered isn't everything that you're responsible for in the text. Just the very, very, very basics, right? Remember, in the text there was putting functions into modules. There was assigning values to parameters themselves. There was a few other things. There was the random function in there, and I didn't do any of that stuff in this video. I just wanted to go over the basics of functions. So yeah, no problem. Hopefully you guys are keeping safe. Before I sign off, is there any last second questions, or is there any examples you want me to do, or anything like that? I'll wait for a few seconds because of the lag. Okay, so it sounds like we're good to go. It was just you and me left at this point. We had a couple of people. I think they already tuned out, logged out a few minutes ago. All right, cool. So I'll go ahead and post this code on Blackboard, and I'll also post a link to the stream in case you want to go back and rewatch or whatever. So thanks for tuning in. Glad to be of service. Please make sure you keep yourself and your family safe. We're going through some hell right now. This pandemic's going to get a lot worse before it gets better. And wash your hands. Practice physical distancing. Am I going to be doing other streams? Maybe. Yeah, I mean, possibly, probably, right? Because I got time on my hands, since working from home and doing this from home now. I'm saving 8 hours a week on commute. So, and if it's useful and it's helpful, why not? And I know for future chapters, I don't have videos already pre-made, so maybe I'll just present the content for those as live streams. But I'll probably do something. I think half hour is probably about right. I think people would lose too much attention span after an hour and 50 minutes or something like that. But I'll probably do at least another couple half-hour little digs in the future. So hopefully that answered your question. I can't tell you right now what I'm going to do and when, but I'll probably will do some more. Okay. Would I consider doing that? Maybe. I mean, well, the thing is that for this class, probably not, because exactly. That's the thing. That's what I would be worried about, is that it might get too confusing, and if it's too confusing, then it would lose its usefulness really quick, right? Because if I'm going through and explaining it and doing everything, I might lose people. They might get confused, or some of those problems might require techniques we haven't studied yet, and so I wouldn't really be able to explain what I'm doing because we don't have the language or tools to really be able to have me explain what I'm doing, right? So it would be kind of like trying to explain advanced calculus without, first explaining to people, basic algebra or something, So cool. So is there any other questions? Alrighty then. Well, I think that I'm I'm going to go ahead and sign off. Thanks for stopping by. And, if I decide to do another one, I'm sure I will. I'll definitely send out another notification about it to let you know. Anyway, have a good night. Take care of yourself, and we'll catch you later.